Hi everyone, my name is Kang. I'm from Group 7. My company name is called BTH Construction. Now I'm going to present my minor presentation for Integrate Design Project 1. Since myself is from Earthwork Department, other than Earthwork Department, there still have three another department involved in this project, which are Erosion Sediment Control Plan ESCP Department, Water Reticulation Department, and Cost and Estimation Department. First is Erosion Sediment Control Plan. The members in this department are Muhammad Adam bin Jamal and also Muhammad Adam bin Noazman, under supervision of Prof. Madhya, T.S. Dr. Tamizi Ismail. Erosion causes soil particles to be separated, entrained, and transported by the soil erosion from their location of origin. Erosion and sediment control is one of the most concerning issues for many large-scale construction projects. Changing of the level of land by grading can cause by wind and water erosion as well. Sediment control can prevent an increase in suspended solid into the river downstream. Manual Salarian Menstrual Alarm MASMA second edition is used as the guideline to provide the minimum standard of procedure as a platform for comprehensive erosion and sediment control plan. A temporary earth drain is used to divert and channel runoff to sediment control facility such as slit trap or sediment basin to reduce the potential for erosion and off-site sedimentation. In this project, temporary earth drain will be provided within the boundary of the project site. A temporary earth drain system must specify Newman criteria if it's to be effective throughout its design life. So it must be able to drain surface and subsurface water away, able to withstand the peak discharge on the site, provided at the top of a cut field slope to safely divert runoff, and also diverted runoff from a disturbed area shall be conveyed to a sediment trapping device. There are many parameters need to be calculated to design the drain, such as average recurrent interval (ARI), average rainfall intensity (I), time on concentration, runoff coefficient, catchment area, estimates of peak discharge, and the right side here is the catchment boundary of project area. The best hydraulic section is chosen from the temporary earth design at its provision of maximum discharge with a given cross-sectional area. In the project, a trapezoidal section is chosen. The function of the sediment control system is to create conditions for sedimentation where the sediment of soil particle in suspension is allowed to settle. Silt basin or wet sediment basin are hydraulic control that function by modifying runoff hydrograph and slowing down the water velocity. The universal soil loss equation (USLE) is a semi-empirical equation used to assess soil losses under different cropping systems and land management practices. This equation is a product of six factors representing rainfall and runoff erosiveness, soil erodibility, slope length, slope stiffness, cover management practices, and support conservation practices. Sediment basins are suitable for nearly all types of construction projects. It is a temporary measure with a design life of 12 to 18 months and will be maintained until the site area is permanently protected against erosion. Sediment basin usually consists of an impoundment, a dam, a riser pipe outlet, and an emergency spillway. This should be constructed before the clearing and grading work begins. So the design criteria of sediment basin is based on the following tables. After the design is done, then we'll have a drawing of design sediment basin. This is the example for zone 1. And we also have zone 2, 3, and also zone 4. From guidelines for erosion and sediment control in Malaysia, the other measures of ESCP are access road, slip fence, wash bay, and also a stockpile. Next is site maintenance. A maintenance program should be prepared for on a fixed interval as well as before and after each storm event. All erosion and sediment control measures shall be constructed and maintained by the developer. In conclusion, the design for temporary drainage flow for all the sub-area is adequate, which is 1.29 meters cubed per second. The estimation for the soil losses is acceptable and also the sediment basin design is able to function well. Next department is Water Reticulation Department. The member of this department are Nur Syahira binti Zainal and also Ain Shakira Izzati binti Abdurrahman, under supervision of Dr. Ewan Hafizi. The components of water reticulation system are storage tanks, type of pipe, type of joint, and a fire hydrant. The objective is to determine the daily water demand, determine the capacity and height of storage water tank, and flow rate and velocity in pipes, and also to ensure the minimum pressure head is specified and determine the appropriate pipe type and also the size. There are many things need to be calculated for the design of pipe system. In this proposed project, the system is designed by using the closed-loop pipe network to analyze the reticulation pipelines. The type of pipe used in this project is high-density polyethylene HDPE pipe with the value of Hazen-Williams roughness coefficient C is 120. Reducing the pressure head loss results in increase in diameter. The water demand for each node is computed according to the SPAN guidelines based on SPAN's guidelines. The head loss must not be greater than 2 meter per 1000 meter for gravity flow. And also the velocity must not be less than 0.3 meters square in order to reduce deposition of sediment and not exceed 2 meters per second to avoid erosion of the pipeline. The residual pressure at each node shall not be lower than 7.5 meter based on SPAN guidelines. The calculation of pressure head at first node is carried out by using Bernoulli equation. And finally, the analysis of water distribution network is done by using ePlanet software. The evaluation of the water tank, the pressure at each node, and also the velocity of water in each pipe is determined through the system until it meets the requirement. This figure is the proposed pipe layout with service pipe. Pipelines are designed at the roadside with a depth of 1.2 meter under the ground. Service pipe for every building or area will connect to the main pipe. The figure shows distribution area of discharge from service pipe to the node. The discharge of each service pipe was transferred to the node nearby. From the summary of ePlanet software, the number of nodes is 36, number of tank is 1, and number of pipe is 52. In conclusion, the analysis of residual pressure head is prioritized in each node, and the head loss in each pipe which lead to a satisfactory result as is compiled with the requirement. The tank was designed with an elevation at height of 10 meter based on the proposed level, which is 60 meter. The type of pipe material chosen in this project design is high-density polyethylene. So the overall design fulfills the requirement and can be used for the proposed project. The last part is cost and estimation. The members in this department are Ruhan Perianan and also Irfan Jafri bin Zuisfa, and its supervision by Dr. Iza binti Aminuddin. There are four main processes in earthwork, which are unloading, shipping, drilling, and compaction. To undertake this work safely and economically, it requires an evaluation of engineering geology of the site. The primary goal of earthwork design is to determine if the proposed level is applicable according to the client's need, the environment, and also the geography. The scope of work include site clearing and grubbing, which are the removal of cutting of tree, excavation, and also backfilling for trench and structures, transportation of soil for cut and fill, grading of site, slope stabilization, and also slope the soil compaction are all included in the definition of earthwork. All earthwork must be done exactly as shown in the plan, and it must be to carry out with a suitable equipment for each work in a proper manner by authorized worker. In huge projects, heavy construction equipment is applied for a variety of purposes. The choice of various heavy equipment type is based on the scope and cost of the project. The machinery involved in this project are excavator, bulldozer, chainsaw, compactor, loader, and dump truck. In this cost estimation, there are also few aspects that are considered as this. The first aspect is the labor cost, affected by level of skill, local or foreigner, and hiring period of the worker. Second is material cost, included transport fee, discharge fee, and additional fuel purpose and purchase. Another aspect is the plant cost, included the fuel output, hiring rate, and operator of machinery. A take-off of cost summary before and after the cost reduction is taken. The pie chart here shows the allocation of total money for each project proposed in detail. So the cut and fill and transport of soil need the highest cost, followed by the removal of tree, stripping topsoil, and other is the minor cost. The bar chart here also shows the difference of carbon footprint of each proposal and other costs. The carbon footprint and other costs has a significant reduction after the cost reduction. This is the bill of quantity before cost reduction. The activity involved are tree removal, topsoil removal, cut and transportation fuel, compaction, and disposal. The total cost of project is 4060,896 ringgit, and also the time taken is 39 days. For the cost estimation after cost reduction, the activity involved are still the same but less cost needed and more time is needed. The total cost of the project has reduced to 3561,354 ringgit. However, the time taken has increased to 100 days. This means that more time needs to be sacrificed because we need to save the cost. Okay, that's all for my minor presentation, and thank you for watching and hope you have a nice day.